Hi, in this video we're going to learn how to find rate law, rate orders, as well as the rate constant K. So first we're given with 3 different experiments with different concentration data. And now we need to find the order of the reaction with respect to ClO2 as well as to OH minus. So if you remember in the few videos where we talked about kinetics, the rate law is rate is equal to K times reactant 1, which is ClO2 in this case, to the nth power, times reactant 2, which is OH minus in this case, to the nth power. And the M and N are the orders of the reaction. Now, in order to find the order in respect to a reactant, we need to set a proportion. And so first we want trying to find M of ClO2. To do that, we need to find two same or extremely similar data points in the opposite reactant so that they can cancel out with each other. So as we can see, 0.050 and 0.051 are extremely similar, and they'll be canceled out when we divide the two of them because they're so similar to 1. So this is when we can use rate 1 divided by rate 2 to set a proportion. And then rate 2 will be the same thing, times ClO2 to the M times OH minus to the nth power. Next, we plug numbers in. Rate 1, as we can see over here, is 0.0288. 0.0288 is equal to K times concentration of ClO2 is 0.050 to the nth power times OH minus, which is 0.050 to the nth power, divided by, next we're doing experiment 2, which is 0.00733. 0.00733 is equal to K times the concentration of ClO2 at experiment 2, which is 0.025 to the nth power, times OH minus, which is 0.051. Now, when you divide these two, it's so similar to 1 that we can basically cancel it out. And then that leaves us with these to work with. And we can also cancel K as well because it appears in both the top and the bottom. Now we have this. First, let's divide 0.0288 by 0.00733. This gives us 3.929 equals 0.050 to the nth power divided by 0.025 to the nth power. This can also basically mean 2 to the nth power, right? When we divide these two out. So 3.929 is equal to 2 to the nth power. We can set up a log. Log to the base of 2 times 3.929 is equal to M. And we plug that into a calculator. Math log base of 2 times 3.929. That gives an answer of 1.97416, which rounds up to 2. So M is equal to 2. And that is the order of the reaction with respect to our first reactant, ClO2. So M is equal to 2. Next, we need to do the opposite for OH minus. We need to do the same thing for OH minus. And OH minus, this time we want to keep OH minus and find two similar or exact same data points for ClO2 to cancel it out. As we can see, there's two 0.25s over here that will perfectly cancel out with each other. So this time we need to do rate of 2 divided by rate of 3. When you set a proportion of rate of 2 divided by rate over 3. And this time it's the same, it's times ClO2 to the nth power times OH minus to the nth power, K times ClO2 to the nth power times OH minus to the nth power. Now rate 2 is equal to 0.00733 is equal to K times 0.025 to the nth power times OH minus to the nth power divided by, not OH minus. OH minus is 0.051 to the nth power. Next we have 0.0218, which is the rate of experiment 3, is equal to K times 0.025 to the nth power times 0.152 to the nth power. Over here, 0.025 to the nth power divided by 0.025 to the nth power basically equals to 1, which is why they get to cancel out. And K divided by K is also 1, so they cancel out as well. Now we're left with this. 0.00733 divided by 0.0218 gives us 0.336. Now we set that equal to 0.051 to the nth power divided by 0.152 to the nth power. And this is equal to 0.051 divided by 0.152. This is equal to 0.3355 to the nth power. Now this would run to 0.336. 0.336 equals 0.336 to the nth power. What will n be? N will be 1. And the first power is itself. So now we found the order of the reaction with respect to OH2 as well. Now what is the rate law? Rate law is rate is equal to K times concentration of ClO2 to the second power, as we found M equals 2, times OH minus to the first power, as we found n equals 1. Now, what is the overall order of the reaction? Overall order is the two combined. Is the two reactants combined. So 2 plus 1 equals 3. Now, finally, we need to find the rate constant K for the reaction, and which include units. Rate constant K, we can find it by using our rate law formula. So our rate law formula is rate is equal to K times ClO2 to the second power times OH minus to the first power. Now we start plugging numbers in. I actually stick with experiment 1, so let's just use experiment 1. So our rate is 0.0288 is equal to K times, if I remember correctly, both of these are 0.50 to the second power times 0.050 to the first power. And I'm correct. Okay. So now to find K, we simply square 0.050 and divide both of this from this. So 0.0288 divided by 0.050 squared, divide that by 0.050. That gives us K is equal to 230.4. We need to save it to 3 significant digits, so let's just keep the point over here. Now finally we need to include the units. What would the unit be? Rate is in m per minute. Now you need to be careful. Sometimes you're given here rate per second and molar per second, and sometimes you're given with molar per minute. So this time we're dealing with molar per minute. So molar per minute rate is equal to K times, these are both concentrations. So both of these will be molar. Molar times molar. So if we divide this side by molar squared, that's basically canceling out these molar squared, these molar times molar, to remain us with a K. So molar divided by minutes divided by molar squared over 1 is basically molar divided by minutes times 1 over molar squared. Now molar and molar cancel out, leaving only 1 molar over here. So our answer will be 1 over molar times minutes. So our final answer, K, which is rate constant K, the units will be molar to the negative first power times minutes to the negative first power. And that is our final answer for K. I'll be doing another example on finding all of these, so that maybe if you didn't understand everything I said in this video, you can see how everything works out in another example, and maybe that will help. Thank you for watching.